For those of you who aren't from Austin, welcome to Austin. It's a fun city, lots to do. I'm what you would call a long-time Austin resident. I've been here for a year and a half, which, as you can probably tell, was just long enough for me to completely lose my Louisiana accent. So, last Christmas, my son told me he wanted a set of binoculars. Binoculars are cool, right? You can look inside and see out into the distance. So that's pretty useful. You're maybe watching the wildlife, seeing the game from the upper deck, stalking your ex. It's fun and useful, right? So binoculars are really great. But how cool would it be if you could take a pair of binoculars and look into them and you could see the future? And not only one future, but several different possible futures. Now, wouldn't that be even more useful? Because you could look in and maybe it would help you solve a little bit of your problems, right? Like, because you can see what's likely to happen. For instance, if you looked through the binoculars and saw that you were going to be lying on the beach with a pile of money, maybe you continue on your current path. You don't change too much. But if you saw that you were living in a cardboard box or living in a van down by the river, maybe it's time to take stock of your decision-making process and change a few things. So with binoculars like these, for instance, you could see how your bridge network, maybe how well it's performing, or maybe if it's not performing at all in the future. And then you could think about what it would take maybe to alter that path. So a good bridge analysis tool is like one of these pairs of binoculars. It can tell you whether your bridges will be lying on the beach with a pile of money or living in a cardboard box. So what is the value of a good bridge analysis tool? We don't do bridge analysis just to do it. It's not an end in itself. It's the output that's what we're after. It's the work plan. So the work plan, the budgets that we want to lock down, it's the alternative strategies that we want to compare. That's what's going to make us happy. So even if the future looks bad, at least we know ahead of time so we can start to plan for it, right? Oh, yeah, you know what time it is. Time for America's favorite game. IUC Feud. You know the song. Let's get it. All right. We surveyed 100 bridge management engineers and asked them a question. Top 5 answers on the board. Here's the question. Name one thing that is affected by the quality of your bridge analysis tool. Now we're going to go through some of the answers here and I'm going to throw it out there. So first up is the confidence in your results. Obviously, I don't like to do bullet points. So the confidence in your results. Like some of you guys here, I've been there walking the halls with my cup of coffee, sitting in my office, looking out the window, thinking it's going to be another beautiful day at the DOT. And then it happens. Maybe it's a phone call. Maybe it's an email. But all I want to do is get up from my desk because the sweat's starting to trickle down and I want to run out, don't look back, and wondering why I ever decided to do this for a living. And the reason for that is, somebody from upstairs wants a bridge analysis. And I know deep down that my tool is incapable of doing that analysis. It's going to take probably at least a week, and they want it by tomorrow morning. So there's a lot of fear there, and you won't have confidence in your results when you don't have a good bridge analysis tool. So let's back to the board. So what's the second answer? Oh, funding allocations. That's another thing that's affected by the quality of your bridge analysis tool. Because when you're asked to do an analysis, what happens? They might start moving money around, right? They're going to ask you how much money we need for bridges in the next 5 years. Oh, well, you're saying we need this much. We're going to lock that in, and maybe we were going to give you more, but now we're going to move that money over to the pavement side. So there's like some serious money ramifications if your analysis is not on point, right? Federal penalties. We all know that asset management is the thing the feds want us to do now. They want us to look at everything and have some performance measures to meet. So if you don't meet those performance managers, there could be some ramifications to the way that you have to designate your funding, right? Number 4, the unknown future. We live in a time of great uncertainty. Everybody knows it. Funding can be uncertain next year and the year after. So even on the short term, it can be uncertain. When you're dealing with the long term, it's very uncertain. So executive staff typically like to look at the long term. And so when you're looking at long term, you want to look at different scenarios and be able to look at different scenarios so you can plan for those. You can be a little more proactive in what you're trying to do. So it looks like, according to my math, there's one more answer up on the board. So I'm going to throw it open and hope to get some audience participation here. What is another thing that's affected by the quality of your bridge analysis tool? Any hands? No? No takers? It looks like I covered it all. All right. Well, let's do this. All right. Will it make me taller? No. Will it make me a baller? Will it help me meet a girl that is cute so I can call her? All right, well, let's see what it is. More attractive, makes you more attractive. Okay. Now, what I mean by that is it will make you more attractive to your boss, certainly, because he's the one asking you for all this analysis. Make you more attractive to your colleagues, because you'll be like the ninja bridge analysis guy. And overall, you just have a better situation at work every day. So standing taller, you'd be the most attractive guy in the whole DOT, right? So let's talk about how we got here. Now, I don't know about you guys, but I took the bus. So in terms of bridge analysis, though, how we got here, this is going to require us to turn the clock back and briefly recap. So a long time ago, we had the MBI, which is a way of rating bridges that states still use today. You know, you rate the deck, superstructure, substructure. Now, got to report this to FHWA, the whole nine. So analysis using MBI data is fairly straightforward, and it works for network level programming pretty well. Well, more recently, states started using element, seeing the value in rating each bridge by the element level. So helped along with a little nudge from the feds, everybody started collecting data on bridges at the element level. So now some states have been doing it a lot longer than others. Some states actually just jumped on after the condition state format change that happened a few years ago. But pretty much every state now is required to collect condition state on every bridge element. Now, so that's all great, and most states have several years of element level data under their belt. So what's the current situation? Well, everybody thought by now, including me, that we would have this, surely since we have like years and years of element data, we would have this problem of element analysis solved. It would be just an afterthought by now. But that's not the case, and it's all across the industry. And there are several reasons why. And I guess the first one is that it's not so easy. You know, when you're looking at bridges from a component level, there's a much more limited situation you're dealing with looking forward when you compare it to element level. As you can imagine, when you're looking at every element on a bridge and trying to extend that out several years in an analysis, it's not an easy thing to do, which is why there are only a handful of viable, truly viable bridge network analysis tools on the market. Because if it was easy, everybody would have one, right? So there's a lot involved in producing a good analysis at the element level. And so our software has made some improvements and continues to make improvements, and we have more planned for the future. So let's talk about some of those improvements. But yeah, just really quickly, this is a diagram of all the bridge elements. So you can imagine when you have to take every one of these elements and analyze it into the future, it gets a little complex. So what are some of the recent changes that we made? Number one, and this took the bulk of the brain power, meetings late into the night, we changed the name from Bridge Analyst to Structures Analyst. Of course, I'm kidding. We just changed the name to reflect the fact that we have primary structures, secondary structures on the inspection side, and we can analyze not just bridges but different types of structures. So the second thing, and these are just the main highlights of recent changes, we incorporated probabilistic forecasting for elements. Now, in our software, MBI components, deck, superstructure, substructure, have deterioration curves and models that are deterministic. In other words, they're basically defined by an equation, and that equation typically doesn't allow for random variables, but that's still in there, and that works great. And I'm going to show you another piece of that in a little while that really works nicely. Gives you some comparison things to do, but we've added deterioration curves for every single bridge element in order to forecast the condition of each of those elements over time. And next, of course, when you have every element, you're going to be needing to recommend treatments at the element level as well. So you're going to need to have decision trees that kind of spell out what treatment gets applied to that element when it reaches a certain condition level. So we have the ability to build those decision trees for each element. And of course, this takes a lot of agency input because every agency pretty much has their own set of treatments that they like to do at certain condition levels. So it's pretty agency specific, but that capability is in there. So now before I talk about element deterioration in a little more detail, I want to talk about something else that was added recently, and this applies to component analysis. I know the title of the presentation was element analysis, but I do want to touch on this simply because it was a more recent addition. It's not something that was added a long time ago. So it's called decision matrix. And what it is it's simply an alternative decision-making process for you to use when you're doing a bridge analysis. So what is it and why did we do it? Well, when you're using standard decision trees, sometimes recommended projects don't make sense, if that makes sense. You end up with some projects where the treatments in real life, you wouldn't put a project together like that. So in order to address that, we now you can just ignore those. You can take the blue pill and just ignore those inconsistencies, or you can take the red pill and use decision matrix, which, what does it do? It improves the treatment sense. Number two, there's a lot less complex decision tree setup, and you'll see in a second, I'm going to show how it's set up. And then it also runs the analysis a lot faster. So let's take a look at one matrix. Now, there's several of these, right? So if you look at this particular matrix, it's substructure is equal to 5. That's on an MBI scale, 0 to 9. So if the substructure is equal to 5, in this case, it's fixed, it's locked in at 5. Basically, it's going to take a look at the other, the package of treatments it puts together is going to be dependent on the superstructure rating and the deck rating. In other words, if the superstructure is at a 5 and the deck is at a 6 in this case, these are going to be the recommended preservation treatments. Now, if the superstructure is in a lower condition, it might automatically say to replace the bridge. It's just makes better sense for your decision-making process. So, as far as element level deterioration, let's take a look first at the component models that we already have in the system, and I'll compare those with the element models. Now, at the component models, this is just a screenshot of a deck decision tree, a deck model tree, and you can select any of the models right here, and it'll show you the curve. Right? This is simple deterioration model over time. What's going to happen to this deck over the course of time? How it's going to deteriorate, and that's determined by an equation. Now, for the element level, what we've done is we've taken that, and the reason we've used a probabilistic model is a couple of things. Number one, The model or the distribution that we use is called a Weibull distribution. There's a couple of reasons for this. Number one, you can imagine when you have a lot of different bridge elements on a bridge, it's going to be, there's going to have some randomness involved when you're looking out in the long term. So this distribution typically is very good at dealing with some of the randomness by assigning probabilities into the model. Also, the model can be shaped in different ways. So the parameters can be shaped to basically mimic whatever you're actually seeing if the model needs to be tweaked. And so it's just a good model to use for the life cycle of things like a bridge, where you have a lot of moving parts. It has a life cycle, and so it's a good model to use. So this is the screenshot in the software of what how the model is kind of set up. And if you look in this one area right here, it's a time-based model, so you can look and see for this particular element, which is a box girder, concrete, you see it'll show you the years that it stays, or it's expected to stay in condition state 1, years is expected to stay in condition state 2, and so on and so forth. And so by changing these numbers, that will change the way the curve shows on the screen. And also, if you select this matrix right here, you can see the underlying matrix behind the curve as far as what percentage condition state, what percentage of that element is in that condition state, and that basically determines or builds the curve. So another thing you can do is if you want to see, now this curve right here is showing 10 years of time. If you wanted to adjust that to, like, let's say 30 years, it would look like that, and 50 years, it would look like that. So you're just expanding the amount of time that you can see on the curve. Now, if you wanted to adjust the actual condition, that the actual time it's going to stay in a certain condition, you would do that in the pane right above, the one that we just showed a little while ago. So now, what are some of the further refinements that we're going to be doing? Now, first of all, there are some element dependencies that exist that if you just throw a decision tree up for every element and run an analysis, you're going to get some things that don't make sense. If you can imagine, as elements deteriorate, the systems can say, okay, fix this element and fix this element and fix this element in this year on this bridge. Well, that might not make too much sense when you take a closer look at it. But if you add some element dependencies, it might start to make more sense. For instance, if you're going to replace a deck, if you're going to replace a deck, now you're not going to take up the joints that are on the current deck, pull those out and pull the guardrail out, replace the deck, and throw the old guardrail back on there and put the old joints back in there. You're going to replace the whole deck. So those joint and guardrail elements and other things that are on that deck are also going to be affected by replacing the deck or some type of rehab. So those types of dependencies have to be addressed and incorporated into the software so that better project recommendations come out of the software. And that's one of the key challenges of element level analysis, is that sometimes all these elements are deteriorating at different rates, and you want to make sure at the back end of the software, at the output phase, that it's outputting things that make sense. Another thing is relating the protective system to the element. It's fairly straightforward to know if you fix a deck and it goes from a 5 to an 8, then basically the benefit there is a 3. However, painting an element, while it's really good for that element, it's not necessarily going to take that element from a rating of 5 to a 6 or from a 6 to a 7. But it will take longer for that to deteriorate because now you got some paint on it. So the problem is, or the challenge is, how to measure that benefit when there's not an actual rating change. You're just spreading out the deterioration. You're freezing the deterioration maybe for a little bit. So that's a challenge that we're working through right now, and actively working to address that. Another refinement is performance trees are being developed. So what does this mean? So let's say the condition state of an element moves or drops past a certain threshold, and according to the index at that point, it crosses into it needs a model change. It needs to switch over to a different model. So that performance tree needs to be developed. Like when it switches models, it's not staying on one model, it's switching to another model. So those trees of jumping from model to model over the course of the deterioration, those things need to be fully fleshed out. Now, another thing that we're working on is comparing the historical deterioration to the element model. Now, currently, we can take, everybody's got a ton of NBI data that they've been collecting for a long time. And you can currently take your NBI data, run it against your NBI model, compare those and see how your data's tracking against the model, see if it needs to be tweaked. Now, we want to take that and kind of put that over to the element model. So basically, got some historical element data, you got an element curve, putting the data against the curve and seeing how well it's tracking the model, or how well the model is tracking your data. So you can basically validate your model. So, so what else we got here? Oh, monetizing benefits into structure value. Now, what does that mean? Your staged bridge network has a value associated with, like a dollar value that is associated with it. Like, let's say it's a $2 billion asset network. Now, let's just say it'd be nice to know, if you did a 10-year analysis, what the structural network value would be at the end of those 10 years with whatever plan you're embarking on, whatever strategy analysis that you're doing, right? So if you spend X amount over 10 years, what's going to be your network value after those 10 years? This is the type of thing that's tangible, especially for non-bridge people and legislators and people that typically ask questions from a high level. If we're spending $1 billion over 10 years to fix our bridges, what are we getting for that? What is it? And if you give them a dollar figure, if you give it to them in monetary terms, they understand it a lot more. So it's really helpful to monetize the benefits into structural value. And finally, risk assessment. We have a framework for risk assessment and risk management. Obviously, FHWA is very high on incorporating risk into any analysis you do. They want it in your TAMP as well. So we want to fully implement the risk assessment process into the software. So, important considerations. And these are just some things that, I've worked with a couple of different softwares over the years. So these are just some important considerations that I could think of when I think of bridge analysis software. Number one, you got 50 states, and they all do things differently. Sure, you have to report to the federal government certain things. But aside from that, everybody's doing their own thing with bridges. It's kind of crazy. I was at a bridge conference last week, and everybody's doing something different. And so the need in the market is for flexible analysis. You want to be able to support our software. We want to be able to support what everyone's doing. Not, okay, we support what you need to send to the feds and that's it. But so we want to be flexible enough to support all the different types of bridge analysis and alternative strategy generation that states are trying to do. And number two, we want to be adaptable to changes. Things change, federal requirements change, the type of analysis you need to do or that you're asked to do changes. So we want to be adaptable to that. And I think we do a pretty good job of kind of responding and staying adaptable and staying on top of the changes that are being made in the market and coming down from the government. Another consideration, if you open your bridge software and this is what you see, it's not really too friendly, right? I mean, how do you even start this thing? Where's the start button? So that's what I'm looking for. I'm looking for the start button on that thing. Your software shouldn't take 10 years and a PhD in software development to turn it on and start working with it. So we need to really focus on usability. And I happen to think our software is pretty usable in that sense. So it's not overly complex, even though what it does can be really complex. And finally, one more consideration for an agency is integration. The days of these programs all working in silos, it's been talked about all morning, those days are pretty much over, or everybody's trying to kind of make that happen where it ends. So you want your software to play nice with others, in other words. You know, especially other systems that can support what you're trying to do. For bridge, that happens to be maintenance, for sure, maintenance, right? It can also play nice with PMS. So these are just two examples of integrations that your software bridge management system should be able to integrate with. And when you have that integration, there's all that data sharing that comes along with that. You get more information, more feedback. For instance, the bridge management engineer with feedback from maintenance. Now all of a sudden, the bridge management office knows what's going on out in the field, what the maintenance guys are scheduling on their bridges. You know, that's a big disconnect in a lot of agencies. So the ability to integrate with other parts of the agency is huge. It's the direction FHWA wants us to go as far as asset management. And so definitely a key part of any software package would be integration. So before we get to questions, I just want to say that we all want to avoid falling victim to the bridge analysis creature. So we're working hard here to assure that bridge analysis is a system that you can have confidence in when you're working toward whatever bridge network goals you have for your agency. So hopefully that was informative, and we'll look at some questions now if we have any. And I got some high-powered bridge people here too, so we got some help with those questions if we need it.
Is this on? Is this on?
Yeah, so Scott, very good. Excellent presentation. So what do we have in production right now using the element analysis? Do we have anybody right now in production? And what's the feedback, if we have any?
Hello? Is on? Okay. I think one of the states that spearheaded this whole thing was Georgia. And a lot of work was done to kind of make sure that they had the capability they needed. I think I don't know how much they're using it, but I know the framework has been put in and the ability to do it is there. But, you know, the question always is, do you have the models that represent what's going on in that state? You know, has there been the research and the data on their side to support the model? Because if the models aren't accurate, then the analysis won't be as accurate, right? So, but as far as the question, I would say that GDOT is probably the one that comes to mind. And I know we've been talking with North Carolina, like this last week, about they really want to get the element analysis part put into their software really soon.
Okay. And New York, not yet?
I don't think so.
No, I mean, I don't know. I'm a bridge engineer, right? So, but I think it seems like we are making. I mean, the data that's at the disposal is more quantitative, that element data. So I would at least think that the work plan, the output of the analysis would be more reliable. I would say, you know, back to your first, you know, before the monster showed up. So, yeah. So, yeah, I was just wondering.
Yeah. I mean, everybody's still having issues with long-term element analysis. Me and Charles had a good talk last week about, you know, when you have a lot of element data and you look at the short term, it can really help you pinpoint where your problems are. It's the longer-term element analysis that everybody's trying to get a handle on, because there's so much inconsistency that can be developed over a long course of time when you have all the elements deteriorating at different rates, and you want to make sure that the output at the end is putting together projects that make sense. So that's where you have to start putting these dependencies in. You want to make sure the decision trees are fully fleshed out and everything. There's a lot of background stuff that has to be put in to make sure the analysis turns out the way you expect it to, or the way you want it to. But the bones are there right now in the software. The deterioration models, the decision tree framework, everything's there. It just it takes agency input to make sure that everything is very accurate.
All right. Since I have the mic in my hand, Not a question really, but just want to emphasize that those guys watching the streaming session outside this house are more than welcome to go into Slido and actually type in a question, and it should show up on our screen right here. All right, Pascal has another question here.
So, I mean, so we've applied that to bridges. Is there any plan, maybe that goes to the product team, to apply that to other asset types like right-of-way assets, things that are, more numerous in nature and less known, so where the probabilistic framework would be called for, right? The forecasting using probabilities versus deterministic modeling, where you need to know each piece, each condition, right? So, I mean, I don't know, maybe that's a more global question here. So.
Well, I just don't know if they're at the point where they're even considering doing that type of analysis. Pavement management is more mature than bridge management. They're like a little farther along, so they're pretty much more confident in their abilities to do long-term analysis because, look, there's only a certain number of pave types, for instance. You know what you're going to do when the pavement of this type reaches this condition. When you start throwing bridge elements, and each bridge is unique and has unique elements on it, and every element has its own deterioration curve, it can get very complex very quickly. Now, as far as these other right-of-way and fleet, I just don't know if they're doing or if they want to do that type of analysis for long-term analysis or not. I have no idea about that. Maybe David, are you guys doing anything like that? No, on the maintenance side, even for like analysis of like performance analysis.
We're going there. We realize that you do need some of that in order to justify funding levels for your fleet and your facilities. So we actually just are right now putting together a section or a group that's equipment that would be doing that kind of stuff for equipment, but our stuff's really old. I think like the average age is 12 years and the average mileage on our passenger vehicles is like 212,000 miles. It's ridiculous. But yeah, there's a need to use it for those types of assets as well.
Well, we probably need to discuss that with product and see what type of demand is there, because I really don't know on that side of the house on those modules what their plans are for like that type of analysis, but we can find out. You're supposed to be helping me answer the questions, Pascal.
That was a discussion.
Charles?
Pleasure. Take it off your hands here, Pascal. So, Scott, one question quickly with the element level stuff. It'd be interesting to know if you had any chats with anyone last week, for instance, about how to kind of bubble that up a little bit. When you're doing your optimization, you're sort of maximizing something subject to budget, or minimizing something, subject to a performance target.
I can hardly hear you.
Oh, sorry. Well, that's
Okay.
Okay. Let's try that again. So, looking at what are you maximizing? When you're talking about optimizing and you're talking about element level, you've got to kind of bubble that element level stuff up, all those CS1, CS2 stuff, into something that you're going to maximize, some single thing that you're going to maximize. I was just wondering if you'd had any chats with anyone last week down in Orlando, for instance, about what that objective function was for them.
The only person I kind of touched on that subject with was probably Dave Juntonen from Michigan. But it was just very high level discussion. We didn't get too deep into that type of thing. Like, what are what's your objective function, and how the element's gonna translate into maybe a grouping of elements that rolls up into maybe a component that you can take to that next level. But I don't think I haven't had that many deep discussions with too many people about that as of yet.
I was at the same conference. There's not too many states that are doing it to that level yet. Most states are in their infancy and, bridge management systems and those kind of things. So there's a working group nationally. I'm actually part of that. That's trying to put together some framework and best practices, but it's all pretty new.
Yeah, I mean, the big elephant in the room, right, is that everybody knows that they have all this element data, but nobody's saying that our element analysis is awesome. Nobody's saying that because nobody's element analysis is awesome right now. They're trying to get it to that point. But, it all goes back to confidence in the results. If the framework is there, and a lot of the work that Kingsley and these other guys and Alex and Mohammed and Pascal are doing is to make sure that the nuts and bolts of the software is there and is transparent so that the output, it really makes sense and you can have confidence in it. And, so we're getting there, but there's probably not a software that can say, yeah, we're ironclad, element level, just use this and you're going to be 100%, because the industry is just not there yet. The bridge management system industry and market as a whole is just not there yet. And you talk to any state out there and, everybody's kind of in the same boat. Some might be a little farther along with what they're trying to tweak and do, but maybe they have some awesome models. Maybe they have some well-built decision trees, but they're still working on some of the inconsistencies in the output. And it's just it's a function of how complex it is. So it's a tough nut to crack for sure.
Okay, yeah, there's a question on the screen now. Can you please read that aloud and see if you can answer it?
Yeah. The question is, can you briefly explain how the analysis handles those dependencies for treatments? That actually might be a Mohammed question. Or Alex, yeah. Somebody give Alex a mic, please. Thank you.
So Alex here. I'm the guy who's developing the black box, so I know what's going on there. So there are two approaches right now. One is we have what we call treatment dependency metrics. So think like columns, treatments, what come in from your decision tree, and rows is what's supposed to be fixed. So if you see treatments that's supposed to trigger other treatments and currently it's not recommended, that project just will be excluded. It's one piece. Second piece is there is a possibility to generate new projects given the recommended projects. So recommended projects is just everything that is recommended by your decision tree. So there is a Groovy that gets information about your entire bridge. So you know all the elements, all the condition states, you know how each element is supposed to be fixed, and then you can develop your custom logic behind how to, using this proposed project to generate the useful one. Hope that kind of made it slightly clear.
Okay. There's one more question that we can get in the little bit of time that we have left. It's just, it says, if the deck has various parts in the 4 condition states, what's the overall condition rating of the deck? Now, obviously, a deck can have different percentages in different condition states, and that's typically on the element level how it's going to be broken down. You got this amount in condition state 1, this amount in condition state 2. Now, what the question is, what's the overall condition rating of the deck? Now, that's taking it to how do we correlate element level to a component level, right? And that's a correlation that everybody's trying to make right now. How can we say that, okay, these condition states exist at the element level? What would that be component level? About a 7? About a 6? We don't know. There hasn't been a correlation found for that yet, not a concrete one. There's a lot of very smart people working on that correlation, and they're having some issues with it. So, I guess in summation, for the answer to that question is, you just have to look at the 4 condition states. That's your condition of the deck. It's not one number you can point to, at least not at this point, because and there's a lot of people trying to relate element ratings to MBI ratings, and the work continues. So with that, I just want to thank you guys for attending.